Our third problem is seating arrangement problem. Here, the real life scenario is that there are 9 members at a new club and they all meet every day for lunch at a round table. I'm sorry, I've drawn an oval shaped table. It's okay. Now, they need to sit such that every member has different neighbors at each lunch. For how many days can this arrangement last? That means all of them are new to the club. Okay. And obviously on the first day, everybody will be sitting next to a new member. So the first day, the arrangement is fine. Now, the second day also maybe everybody can get to sit with a new member. But we don't know for how many days this can last. We need to find out that. Again, we convert our real life picture into a graph. Okay, here the 9 members are represented by 9 vertices and the neighboring members are represented by means of edges. Since member 1 was sitting near to member 2 and member 9, in the graph we will have an edge between 1 and 2 as well as between 1 and 9. Similarly, we draw all the edges. Okay. Now, how many such graphs can be drawn? Each having the same 9 vertices but entirely different set of edges. So, if you can draw n number of such graphs, that means this arrangement can last for n days. Okay. Now, we will see how many graphs we can draw with these 9 vertices and 9 edges. Of course, a solution exists, right? At least one solution exists because on the first day, everyone can sit at a new neighbor. Okay, the first day is anyway success. Now, on the grounds of graph theory, I can say that since it is possible to draw at least one edge disjoint circuit in a complete graph of 9 vertices, we can say that a solution exists. Now, what about the remaining solutions? Now, total how many solutions are possible? Now, this is purely mathematical, okay? You are not going to understand anything here. It's okay. We will recall these problems and these formulas later when we learn the related concepts. Okay. Now, by means of graph theory, I can say that the number of edge disjoint circuits in a complete graph is given by n minus 1 by 2 if n is odd and n minus 2 by 2 if n is even, where n is the number of vertices. Okay. That means here in the graph that we obtained has got 9 vertices. That means n is equal to 9 odd. Then the number of possible solutions is equal to n minus 1 by 2. That means 9 minus 1 by 2, that is equal to 4. Okay. Hence, from the formulas of GT, we got the proper answer. That is 4. That means for the first 4 days, all these 9 members can sit such a way that every time they have got a new neighbor. Okay, for first 4 days they can sit in such a way. On the 5th day again their neighbors will start repeating. Okay, so this solution we found using the formulas of GT. These solutions are obtained using the concept of edge disjoint Hamiltonian circuits in a complete graph. We will learn this later. Need not worry at all. Now, the first arrangement is like this. Member 1 sitting next to 2, 2 sitting next to 3, 3 sitting next to 4, 5, 6, 7, 8, 9 and finally 9 again being the neighbor of 1. Okay. So that is the first arrangement. On the first day, all members will be sitting in this way. Okay. Here it is represented by means of a zigzag type of graph. Here the vertices 1 to 9 represent the members and these edges represent that neighbors. Here the vertex 1 is connected to vertex 2 and vertex 9. That means member 1 is sitting next to member 2 and being a neighbor of member 9. Similarly, vertex 2 or member 2 is being a neighbor of member 1 and 3. 3 being the neighbor of 2 and 4. 4 being the neighbor of 3 and 5. Like that it goes on. Okay. So this is the arrangement on the first day. Okay. Yeah, this is how it goes. The graph actually goes from 1 to 2. 2 sitting next to 3. 3 is sitting next to 4. 4 is sitting next to 5. 5 sits next to 6. From 6 again 7. From 7 again 8 to 9 and 9 back to 1. Now we get a circuit. Okay. And the order of the circuit is like this. 1, 2, 3, 4, 5, 6, 7, 8 and last again 1. This is a circuit. Okay. This is the arrangement on the first day. Now we are going to see how we'll make these people sit so that everybody has got a new neighbor. How is this possible? Okay, this is purely based on certain theories of graph theory. Okay, to get the next arrangement, there is a rule. Okay, it is based on a rule. The rule is that rotate the imaginary circle in anti-clockwise direction by one step, such that all vertices get a new position, and then again start from vertex 1, move along the adjacent vertices until you are finally back to 1. Okay, I'll again explain to you. Imagine that there is a circular ring. Okay, imagine like this. Now move all the members one step in the anti-clockwise direction. Okay, let member 5 get up from that seat and go and take the seat previously occupied by member 3. Similarly, let the member 3 stand from that seat and take the seat previously occupied by member 2. Similarly, everyone must occupy the seat in their anti-clockwise direction. Okay, now let's see what happens. Everybody is moving in an anti-clockwise direction. Okay, they all move to a new seat. Okay, this is on the second day, but the member 1 is still on his seat. He is not moving. Okay, now you see everyone has got a different neighbor or not? Yes, exactly. Everybody has got a new neighbor now. Before, on the first day, 1 was sitting near to 2 and 9. Now, member 1 is sitting near to 3 and 8. Right? Similarly, you can check it out. Everybody has got a new pair of neighbors. Okay. So, here 1 is sitting next to 3. 3 is sitting next to 5. 5 is sitting next to 2. 2 is sitting next to 7. 7 sitting next to 4. 4 sitting next to 9. 9 sitting near to 6. 6 is being the neighbor of 8. 8 again being the neighbor of 1. Okay. Now we get a new circuit. Okay. Right. Now on the third day they all came to the club. Now again they all have to follow the rule. Okay. They all have to move one step in the anti-clockwise direction. Okay. And take the new seat in that direction. Suppose if there is an imaginary circle. Now everybody is moving their seat towards the anti-clockwise direction. Okay. Now everybody has been seated. Note that 1 is not moving from his seat. 1 is still sitting there. However, one has got new set of neighbors. Okay, on the first day one was sitting near to 2 and 9. Second day it was near to 3 and 8. Now 5 and 6. Similarly, you can draw and check it out whether everybody has got a new pair of neighbors. Yes, now we get a new circuit. Our new circuit is like this: 1, 5, 7, 3, 9, 9 to 2, 2 to 8, 8 to 4, 4 to 6, again 6, back to 1. We get a new circuit. Okay. Again, we repeat the process to get a new circuit. Okay, everybody will move one step towards anti-clockwise seat. Again, get seated. Today, on the fourth day, member 1 is sitting next to members 7 and 4. Of course, 7 and 4 have never sat close to 1 before, right? Yeah. So this is again a new seating arrangement, right? Yeah. So this is also a solution. Here also you get a new circuit, like our circuit goes like this: 1, 7, 9, 5, 8, 3, 6, 2, 4 and back to 1. This is again a new circuit.